What's up everyone, Michael here. Today I've got an awesome tutorial for you. We're going to be learning how to put any data from any API on the internet onto the blockchain. Chainlink External Adapters combined with a running Chainlink node allows you to call any API through the Chainlink interface from your smart contract. If you're familiar with Chainlink, you might know that there is something called a core adapter. So why would you use an external adapter over a core adapter? Basically, an external adapter allows you to do a few more things. The main advantage is that you can do computations off-chain. So if you want anything other than the raw API results, for example, if you want the maximum out of a series of values that's returned by the API, you can do that computation off-chain if you're using an external adapter. This saves on gas for the Ethereum contract and makes it cheaper to use. The other reason is if you're using an API that requires a private key. Using an external adapter allows you to set environment variables. And so this lets you use a private key to access the API. During the tutorial, we're going to be using this GitHub that Chainlink has provided. It's a template for an external adapter in Python. I'll be sure to link this in the description below. To get started, make sure that you have Git installed on your computer. Open the terminal and go ahead and clone the repository from Chainlink. Now we can cd into our repository and open it in our favorite text editor. I'm going to use Sublime. Now that we have the code open, I'll give you a quick run through. So the most important file is this adapter file. This is what we're going to change in order to add our custom API. You can see that right now they have this crypto compare API in there as a placeholder. The app file is used if you want to run the external adapter locally. The bridge file contains helper code that is used to connect to the Chainlink bridge. Jumping back over to our adapter file, which is where we're going to be working for most of this tutorial, we can take a look at the base URL. In our case, we're actually going to be using the NOAA Tides and Currents API. I'll drop a link in the description. Let's go over to their API documentation. So here we have the NOAA API. As you can see, they have documentation on the side for some of the different things. Let's go over to sample URL and see what we have here. So as you can see, most of the API query data as to what we're actually querying from the API is structured inside the URL itself. So this API specifically doesn't require parameters on the post request. You can just send the API at the right URL and you'll get the data that you want. One tool that we're going to use to test our API is called Boomerang. So Boomerang is a simple web tool that allows you to do simple API requests from your browser. And it's really useful for seeing the response and being able to add, you can add headers, so you can add a private key, you can add parameters. And so this is a good way to test your API that you set up once the external adapter is set up, but also to test and just kind of get familiar with APIs from third parties. So as you can see, I've already put in the NOAA Tides and Currents API URL into here, and I've actually queried it once. Since this was a few days ago, let's go ahead and change the date. So in this date field, begin date, we can see this was March 14th. So let's change that to the 15th. And end date also the 15th. And they have the actual times too. And so our station ID, so basically what this is going to do is it's going to pull data from a weather station. And this station specifically is going to be on Virginia Key, which is in Biscayne Bay outside of Miami. So let's go ahead and send this API request and see if we get a good response. Okay, so we can see we got a response. It's from March 15th. So there's metadata associated with the response and then actual data. So we know this API is working. We can see the response data that we're expecting. Let's go ahead and jump back over to our code and prepare our external adapter to handle this API. Because our API is URL based and all of the parameters are built into the URL and handled on the API's backend, we actually don't need these to and from params. So we can go ahead and delete those. It might be useful to actually run through the code really quick. So let's go ahead and run through and get an overall idea for what the code is doing at each step. So this base URL is going to be our URL. So this init function, so in Python, an init function is the first thing that's called when a class is initiated. This ID is a required attribute in Chainlink External Adapters. Every call needs a job ID. Request data is actually the requests that we're getting from the Chainlink node or from the smart contract. So this is the data that's being input into our external adapter. And so this is the data we can use to tailor our API requests to our external API. Validate request data is a function that you can see here on the screen. And this is what's used to make sure that the request data is in the format that we're expecting. In our case, we're expecting a weather station ID. So what we could do if we wanted to was create a library of valid weather station IDs and check to make sure that it's part of that library. If the validation fails, which means the request coming from the smart contract is invalid for some reason, this will trigger this self.result error where we can send an error message back. If we want to, we can customize this to give more information about why it's actually failing. Underneath the validate request data function, we're instantiating a bridge class object. And this is just going to help us interact with the Chainlink bridge. The next class is the set params class, which you can see down here. This is where we take information from our request data and use it to structure the parameters that we're actually going to use in our API request to the third-party API. Finally, we have the create request function. This is a function that takes all the information that we already have with the parameters that we've set, with the information coming from the smart contract, and then it tailors that into a request that is sent to our third-party API. Then this is where we can parse the data from that request and decide what will be sent back to the Chainlink node, and therefore the smart contract. In the name of keeping the tutorial simple, we're only going to do a very basic external adapter, and so some of these functions we won't be modifying or we'll be able to delete. For validate request data, we can go ahead and keep that the same and not do any fancy validation requests. For set params, so this is basically going through the params from the request data and setting them into our local param function, so we can actually go ahead and delete all of this. The only parameter from the request data that we're really worried about is our station ID for our weather station. So we can go ahead and get that by doing self.station ID. So this is saving the results to a class variable, which is station ID, that we'll be able to access later. And then we can pull in request data that's coming in from the smart contract request. That's going to be under self.request data. We can call the .get function to get a specific parameter, and we're going to get station ID. Next, we're going to create the request. So because we're not using any of these parameters, we can delete what's inside the brackets. We do still need to pass the parameters as an input to our bridge, but we can leave that empty for now. Now we can go ahead and build our URL to call the API. So we actually don't need to put it here. It might not be the cleanest version, but I like to go ahead and pull it down here because this is where we're going to be working with it. So go ahead and paste that in to our create request function. And I'm going to go ahead and copy the Noah API URL that we're going to be using. Okay, I've copied that in, and I'll make sure to link that in the description. But as you can see, it's a really long URL, but there's one part of the URL that we want to change depending on the request data that's coming in, and that is our station ID. So here you can see our station ID. We can change that using the Python string editing. So if you do some curly brackets here, right where that portion of the string was, and then you type dot format, here we can add our station ID. In this case, the station ID is self.station ID. Okay, so this response is actually sending the request to the API. So this data is the response that we're getting from our third-party API. I'm going to go ahead and add a comment just so we can keep our head straight. Okay, the next thing we want to do is parse the response from the API. It's important that we do as much computation and parsing as we can inside of our external adapter, because anything that you do inside of an Ethereum contract or anything that you need to do is using gas cost. So in our case, we want to be able to provide the temperature data directly back to the smart contract. So let's jump over to Boomerang and see where our temperature data lies. Okay, here we are in Boomerang, and we can see that in order to traverse the response, we'll have to go first into data, and then there's actually a list of different dictionaries. And so we can just take the first element of that dictionary, and we'll go ahead and take this V as a value for the temperature. Okay, so let's go ahead and access that. So quick comment. Okay, and we're going to be putting our data into the self.result attribute of this class. And that's what's going to be used, as you can see right here, to put that into our data that we end up sending back to the smart contract. So the actual data that we want to get is going to data. And as you remember, in the Boomerang structure, we have to go through data, then take an element of the list, and then we want V, which is the temperature. We can delete this line, which is the line that we just replaced. And there we go. We're ready to go ahead and test out our external adapter. Go ahead and save this and then open up your terminal. Okay, here I am in the terminal, and I'm in this CLEA Python template directory. So in order to actually test our external adapter, we're going to have to install the dependencies. So to do that, if you list, there's already a pip file, and so we can just do pipenv install. Okay, that all looks good. Now remember that it's the app file right here that's actually able to run our external adapter locally. So we can go ahead and run this using pipenv run python3 app.py, which will run it through our pipenv virtual environment with all the dependencies. Okay, it looks like we're up and running, and our API is running at this local port. So go ahead and open up a new terminal window, and we can do it. Here we are in our new terminal with this command. You can see that the data object that we're passing in, it has the ID. So remember that for Chainlink, it's required to have the job ID. And then it has this data parameter, which is where we include our specific data that we're going to parse through. In our case, that's the station ID. I'll make sure that I put this command in the description. So let's go ahead and run it and see if it works. Okay, it looks like there's an error, and luckily we have an error message. Adapter object has no attribute base URL. So let's go ahead and back over to our code. Okay, so let's go ahead and see if we can fix this. No attribute base URL. So it looks like we're using base URL here and self.base URL in the actual request. So let's just delete that self, save that, and see if we can go ahead and run our code again. Awesome, it works. The next step is to get this onto AWS so that we can access it from anywhere, not just locally. So the last thing that we can do locally after testing our API is actually put our external adapter into a zip file, which is what's going to be used by our AWS Lambda function. If you look at the GitHub for the external adapter template, they have good instructions on how to actually create the zip. So we can go ahead and copy those. So this log function is basically taking all of the packages that are being used in our pip environment and putting that into this requirements.txt file. Then we're actually installing these from the requirements file into a package file, so it's all available in code. And then we're packaging everything, including the package, the main function, adapter, and bridge Python files, all into a zip package, which is what AWS is actually going to read from in order to create the Lambda. Okay, so let's make sure we're in the right place, and we can go ahead and just copy those commands right over. So first, we'll lock the current requirements. Next, we'll install those into a package. And then finally, we'll put that all into a zip file using this final command. And so now we should be able to see our zip file. We have the cl-ea.zip. So that's what we're going to be using over in our AWS Lambda. Okay, so here I am in our AWS. Let's go ahead and go over to our Lambda function. So just you can search Lambda. And now what we're going to do is we're going to create a new function. So go ahead and hit create function. So we're going to author it from scratch. Choose any name you want for this. I'm going to do YouTube CLEA for external adapter demo. And then for our runtime environment, since we built everything in Python, we're going to be using Python 3.7, which is what the docs on the template suggests that you use. So going to the execution role, we're just going to keep this selected. Go ahead and create a new basic role with Lambda permissions. And now we can go ahead and hit create function. Don't worry about the advanced settings for now. Okay, so here we are in our function, successfully created. So this code source is what's actually is the core of the function. It's the actual code that's being run. For us, we have everything in the zip file that we created. So we can go ahead and upload from a zip file. And then go ahead and choose the zip file on your computer to upload it into AWS. Okay, I have my zip file here, this cl-ea.zip. And so I'm going to save that. Okay, so as you can see, we have our file here, our zip file, and we have, if you just take a glance, you can see like Flask is here, requests, URL lib. So these are all packages that we had installed in our zip file. And then here are our main files, the adapter, bridge, and main file. So in a Lambda function, everything is run through a specific function in our code. And so we need to select that function. By default, it's this Lambda handler function, Lambda function.lambda handler. But so as you can see, the handler is here. And so this is where all requests run through. This is kind of like the main function for a Lambda function. So this is kind of what directs like what's going to happen in the code. Luckily, Chainlink and their template, they have a wrapper to make this easy. So we can go ahead and add this Lambda function, Lambda handler. We're just going to change that. So in the Chainlink template, everything runs through the main.lambda handler. So set that to main.lambda handler and then go ahead and save. Okay, awesome. So that part is all set. The next step is we need to find a way to allow external sources like the Chainlink nodes to actually connect and make requests from our external adapter. And to do that, we need to add a trigger, and we're going to create an API gateway, which is basically like creating a public endpoint for this Lambda function so that people can call it from the public endpoint, and it will operate just like an API at a URL. So go ahead and select Add Trigger, and then we're going to choose API Gateway. So under API, we're going to choose Create API, and that's actually going to be a REST API. For security, in this case, I'm going to set this to open. If you have a relationship with a node provider or you're running your own private Chainlink node, you might be able to create an API key for them to use. But for now, for testing, let's just do open. Okay, we don't have to worry about the additional settings, so let's go ahead and add that. Okay, so now let's go into our API gateway trigger. So now we have to set it up to actually work well with our Lambda function. So go to integration request and uncheck this Lambda proxy integration. Go ahead and hit OK. And OK. So now this is allowing the API gateway to invoke our Lambda function. Okay, so now we have to basically reset our Lambda function. So let's go ahead and go back. I have it open here. So let's go to Lambda functions, function overview again. And so we have this API gateway. We can go ahead and delete that. And then we're just going to re-add it in order to reset that security. Okay, so now we can hit Add Trigger. And then for the trigger, we can select API Gateway. And now we have our existing one. In this case, it was the YouTube CLEA demo. And for the deployment stage, we can just do default. Okay, that's all set. The last thing that we can do is actually test this API endpoint that we've set up on AWS. So let's go ahead, look at details. We have the API endpoint here. So go ahead and copy that, and then go back to your terminal so we can test it locally on our computer. Okay, so I'm back here where we had our last command to test it locally. The only difference is we're going to be changing the actual endpoint. So here we had localhost 8080. So go ahead, delete that, and then paste in the link for your specific API endpoint. And then go ahead. You can keep the same station. Everything's going to be in the exact same format as when we tested locally. And running it should give us the same response. And then go ahead. You can keep the same station. Everything's going to be in the exact same format as when we tested locally. And running it should give us the same response. Awesome, it worked. As you can see, we have all of our response here. As expected, you have officially created a Chainlink External Adapter with a custom API. Great work. So now that you have your Chainlink External Adapter up and running with your AWS endpoint, you need to get it onto a Chainlink node. There are two ways to do that. First, you could just ask a node operator. You could post, if you go to market.link, you can post your external API here, and you can also request that node operator run your external adapter. Looking at the Chainlink market, if you go to adapters, you can see the current adapters that the community has added. So you can go ahead and add your adapter here. If you want to actually ask someone to run it, it's a good idea to post it here, but you can also go ahead on the Chainlink Discord and ask a node, someone running a node, to go ahead and run your external adapter. The community is super helpful, and they definitely get you up and running. If you want to run your external adapter in your own node, but you don't have a node yet, go ahead and watch my last video on how to get a node, Chainlink node, up and running on AWS. If you already have a node up and running, I'm going to explain how you can connect your Chainlink external adapter to that Chainlink node in my next video. So go ahead and subscribe in order to see that. If you liked this video or if it was helpful, please drop a like and a comment below. It really helps out the channel, and it really gives me the motivation to know that I'm helping you guys and to make more videos like this. And last but not least, I really encourage you to check out the Chainlink Discord and the Chainlink channel. They have a lot of really good resources, and they're actually starting a hackathon soon, which would be a fun way to put some of these coding skills that you're learning to work. If there's any other content you'd like to see, like videos on tokenomics or Chainlink research, or even other tutorials for other projects, drop a comment, let me know, and I'll probably make a video on it. Thanks again for watching, and I'll see you in the next video.